Good afternoon. All right, you're welcome to 2022/2023 pharmaceutical calculations revisions. I don't know, as I told you in our last class, that this revision will be a kind of is a question-oriented one, and I leave it to you to bring up any question from any topic. But I have always advised to ensure that you cut across all the topics. So I don't know if there's any question would like us to take a look at. Anyone? Okay. Call the question. Okay.
Says that the product consists of a solid bed. 2 grams of a solid ingredient is contained in 500 grams of product. A further 250 grams of vehicle is added to the product. The question is, find the concentration of the dilution mixed as a 1. Percentage strength, 2. Ratio strength, 3. Amount strength.
Okay. A product consists of a solid vehicle, right?
Yes.
2 grams of the solid medicament is contained in 500 milligram of the product. A further 250 milligram of the vehicle is added to the product. Find the concentration of the diluted mixture as a percent strength, ratio strength, and amount strength. You know, from this question, you know the solid, the vehicle, both the vehicle and the solid and the ingredient, they are all what? Solid. They are all what? Solid. So, because they are all solid, the convention we talked about, where you have solid in liquid, doesn't hold here. The weight amount can be in gram, it can be in kilogram, it doesn't matter. But what matters is that the amount of the ingredient, which should be at the numerator, must be in the same unit with the entire product. Okay, let's look at the question again. A product consists of a solid vehicle. Good. 2 grams of the solid ingredient is contained in 500 grams of the product. So initially, from the beginning, the product has always contained the product. Initially, you have you know that concentration, amount concentration is certain as saying the amount of the ingredients over the amount of the what? Entire product. This is actually the mean of amount concentration, amount strength. This is the actual definition of the amount strength. We are told that the product has 2 grams of ingredients in 500 grams of the what? Of the product. So the amount strength is the amount of ingredient is what? 2 grams over what? 500 grams. This is the initial amount strength. But we are told that further 250 grams of the vehicle was added to the product. So the concentration will change. So they added 250 milligrams of the what? Of the vehicle. But they didn't add anything in the what? In the ingredient. Nothing is there, 0 grams. So the total amount of ingredient is there is still what? 2 grams. But the vehicle will add to the amount of the entire what? Product, making it what? 750 grams. So the amount strength now is this 2 grams over what? 750 grams. So this will give us, if you break this thing down now, you see what it will give us. Now, but there's another point I want to make. I want to let you know. The question: were we asked to find the amount strength in a particular unit? Check it.
That one is, as in the question asks us to find the amount strength, but they did not give any units.
Okay, let me see. Okay, this is the amount strength. You can break it down further. If you like, you can convert this one to what? Milligram. All together, you can convert this to what? To milligram. If you convert this to milligram, you have what? 2,000 watts. True or false? Yes, milligram over what? 750 grams. Now, if you cancel, if you divide, 200 divided by 75 is around 2.5. Confirm. It's around 2.5. 2 point what? Okay. Okay, it's okay. 2.6 what?
Just 2.7.
Okay, good. 2 point what? 7 milligram per what? Gram. If you like, because you were not told where you should leave it, you can still leave it as a 0.2, divide 2 gram by 250 gram. Sorry, 750 gram.
0.002666.
You can still leave it at 0. What? 0027 what?
270
gram per gram. But watch out. Do you know why it's not good to leave it like this? Because this gram per gram doesn't really sound somehow. So you move this one to what? Milligram. So leave it like this. 2.7 milligram per what? Gram. Okay? This is the what? Amount strength. From this amount strength now, you can start moving it to what? Percent strength, ratio strength. Now, from here now, look up. At this level here now, you can move from here. You can move it from here to percentage strength. Are you there? You can move it from here to what? Percentage strength. If there are two, actually percentage means how many will be in 100 grams. If there are 2 grams, in what? 750 grams. How many will be in what? 100 grams. So that is the meaning of percentage. How many will be in 100 grams? You can do like the S is now equal to what? 2 grams times what? Over what? Times what? Yeah, that's what it is. Or if you like, you can simply forget. Look up. If you like, you can simply forget long story. Simply do 2 grams over 750 grams times what? 100%. Gram, cancel gram. Multiply this out, you have 2 point what? 7% weight in what? Weight. Is what? 0 point. Okay. Let's see. Okay. Do 2 grams times 2 times 100 is 200. Divided by 750. Sorry. 0 point what?
0.266.
0.2 what? 7% what? Because we are talking about both the product, vehicle, and the ingredient are what? Solid. So you leave at 0.27% weight in weight. That is a percentage concentration, or the percentage strength. Now, if you like, again, you can from here now. This is the junction through which you can go to the different concentration. If you like, now you move this one that what? Ratio strength. Remember the meaning of ratio strength. You express it in this for 1/r. That means you keep dividing this until the numerator becomes what? 1. You stop. This is how it should appear, 1/r. If you don't want to write it, it becomes 1 in what? 1 in r what? Weight, because of solid is solid. Now here, what it means is that you keep dividing until the numerator becomes what? 1. Let's do it. Here is 2 gram over 2 gram, right? 2 gram over what? 750 gram. Gram will cancel gram. 2 divided here is 2 is what? 1. 2 divided 750 is what? 375. So this means 1 in what? 375 what? Weight in what? Weight. This is ratio what? Strength. Another question, which one?
100 mil of a number 4. 100 mil of a 1 in 50 weight per volume solution is diluted to 100 mil. And the question is, find the concentration of the diluted product as percent strength, ratio strength, and amount strength in bracket milligrams per mil.
Okay. I come to the question. 100 ml of a 1 in 50 weight in volume solution is diluted to 1000 ml. Find the concentration of the diluted product as A, percentage strength, B, ratio strength, C, amount strength in milligram per ml. Now, let's look at this question critically. Okay, the question says 100 ml of a 1 in 50 weight per volume solution is diluted to 1000 ml. Now, there's something I want to let us know here. You know, the volume is 100 ml. The concentration is 1 in what? 50 weight in what? Volume. Then the final volume it was diluted to is what? 1000 ml. Now from this, what type of strength is this? Ratio strength, right? And this is the volume of this concentration. Now for us to be able to solve this question, we are told that this thing was diluted from this to this volume. That means the vehicle was added, or a diluent, which is maybe water, was added for the volume to increase from here to what? Here. Now let us now move, for us to be able to have a clearer view of what this will look like. Let's move this amount strength to, this ratio strength to what? Amount what? Strength. Let's move this ratio strength to what? Amount strength. Now, we are told that this is 1 in what? 50 weight in what? Volume. Which is certain as saying 1 over in what? 50. This 50 now, remember what I told you about the convention.
You cannot say this one now, 1 gram over 50 ml.
Good. That's where I'm going to. That's where I'm going to. I wanted to explain why you should use gram and mil, because we are talking about weight in what? Volume. The weight must be in gram. The volume must be in what? Mil. So this has been reduced to this lowest distance, making it what? Gram over what? This actually means, this 1 in 50 means 1 gram in what? 50 mil. But this is the volume, 100 mil. This is the volume, 100 mil. And this is the strength, 1 gram. That means each 50 mil of this volume contains what? 1 gram. Therefore, because of this 200 mil, therefore the entire volume is what? If you have 1 gram in 50 mil, how many gram will be in 100 mil? S is what? 1 gram times what? 100 mil over what? 50 mil, which is what? 2 gram. So, do you know what this means? In this 100 mil of the initial solution before dilution, it's actually, we actually have 2 gram in what? 100 mil. This is actually the amount concentration. There is actually what? 2 gram in what? 100 mil. Before the dilution. Remember what we discussed about dilution. In dilution, you are not adding any ingredients again. You are just pouring the what? Vehicle, which diluents. So if you like, pour 1 million mil of water here. This 2 gram will remain what? 2 gram. So as they diluted from 100 mil to 1000 mil, if you like, pour 2000 mil of water. This thing will still be what? 2 gram. Do you know what this means? That the final strength is what? This same 2 gram over the final volume of the product, which is what? So the actual final concentration of the new diluted form is what? 2 gram in what? 1000 mil. This is actually the final concentration. Are we together? Now, but the question says, find the percentage strength of the final what? Of the diluted product. So percentage strength now here, there is 2 gram in what? 1000 mil. So how many will be in 100 mil? So just simply multiply by what? 100. So this is what? What's the answer? Is what? 0.2 what? Percent weight in what? Volume. Is it clear? Now, from here again, you can calculate the what? Ratio strength. There is 2 gram in 100 mil. So let's keep dividing until we have 1 here. So we have, this will give you 1 gram over what? 500 what? This is me now. 500 mil. So this actually means 1 in what? No, don't put mil again. Just move it to 1 in 500 weight in what? Volume. This weight and volume has covered this gram and mil. So no need. If you put it here, you fill it. You have used this gram for weight, mil for what? Volume. Simply, this is how to write percentage, ratio strength. Okay?
But what if you do 2 gram divided by this 1000 to give you another
It will give you what?
0.00.
You are calculating the amount strength. That if you do that one when you want to calculate the amount strength. Look at the question. The question says calculate the last question says calculate the amount strength in what? In what?
In
Milligram per what? Mil. Now, remember, we are still working with this. Let's convert this to what? Amount strength. But we are told that it should be milligram per minute. That means we should convert this gram to what? Milligram. So it becomes what? 2 what? 2,000 now. If you want to convert gram to milligram, you must multiply by what? 1,000. Yeah. There are 1,000 milligram make 1 gram. So if you want to move 2 grams to milligram, what are you going to do? 1,000 milligram make 1 gram. You want to move 2 grams to milligram, what are you going to do? Multiply. So this is what? 2,000 what? Milligram over what? 1,000 what? Mil. So this 1,000 will cancel 2,000. So we are left with what? 2 milligram per what? Per what? Per mil. We are left with what? 2 milligram per what? Per mil. This is the. So this one is the what? Percentage strength, ratio strength, amount strength.
Volume per volume solution is needed to produce 5 liters of a 1 in 2,000 volume per volume solution.
What volume of what?
Of a 1 in 400 volume per volume solution is needed to produce 5 liters of a 1 in 2,000 volume per volume solution.
Okay. What volume of a 1 in 400 volume per volume solution is needed to produce 5 liters of a 1 in 2,000 volume in volume what? Solution. Now, initially, look at this question. Initially, you dilute a stock solution. A stock solution is the solution the initial solution you have. That is what we call what? Stock solution. So if you dilute it, you now produce a dilute what solution. But here now we are asked what volume of a 1 in 400 volume per volume solution is needed. So it's from this one, the initial concentration of is 1 in 400 what? Volume per volume. Is from here. This is the one you will dilute to produce 1 in 2,000 what? Volume per what? Volume. Okay? Okay? Now, you can use dilution formula for this question. You know the dilution formula, right? C1 V1 is equal to C2 V2. You know that one now. Initial concentration, C1 is initial concentration or the concentration of the stock solution. V2 is the volume of the stock solution or volume of the initial volume. Then C2 is the concentration of the dilute solution you formed, while V2 is the volume of that dilute solution. And for us to be able to solve this question well, we can convert this ratio strength to percentage strength, so it will be easy for us to handle. Okay, we can convert. So from this whole thing now, from what I said, using dilution formula, we state that C1 V1 is equal to what? C2 what? V2. See from the question, what is C1? Call it what is developed C1 for the question. So 1 is to what? 1 in what? 400 volume per volume. Let's convert it to percentage strength immediately. This certain are saying 1 over what? 400 times what?
100%.
Which is what? You know, this volume, this can be male per male, okay? Which is what? 0. What?
0.75.
25 what? Percent volume by what? Volume. Now, V1 is what? Check well. V1, no V1. What did the question say? What is the volume of? No, check, read the question well. We are giving the volume of this first concentration.
Okay. 1 in 2,000.
Volume, is that in volume? Did you understand what I said here? Now C1 is the concentration of the stock, the one you want to dilute. You said it's 1 in 400, right? Then what is the volume of that one you want to dilute? That's what I'm looking for now. The question says what volume? The question says what volume of this concentration? Read that thing well.
What volume of 1 in what volume of a 1 in 400 volume solution is needed to produce 5 liters of a 1 in 2,000 volume solution? So we are finding for the
V1 is because they gave us a stock solution, but they didn't give us the volume of its volume. They asked us to find the volume of that stock solution. That's why they say what volume of a 1 in 400. That means what volume of this concentration do we need to produce under strength of volume of 5 liter? Did you understand this? Are you sure? Are you sure? Now, so the V1 is what I'm looking for. We don't know. We call it what? Put question mark there. C2 is what? For the question, C2 is what?
2 is 1 in 2,000.
Good. 1 in what?
2,000.
1 in what?
2,000.
2,000 volume. Let's move it to percentage concentration. It becomes what? 2,000 times what? 100%, which is now equal to what? 0.05% what? Volume in volume. This is C2. If you watch now, 0.25 and 0.05, which one is higher? So that means it was diluted from here. So because the concentration did what? Decreased. Is it clear now? Now, but the V2 is what? 5 what? Liter. So let's use this formula to find V1. So C1 is what? 0.25% volume per volume times V1 is what? We don't know. V1 you don't know. Because that's what I'm looking for. C2 is what? 0.05% volume in what? Volume. Times V2 is what? 5 liters. So let's make this V1 the subject of the formula. We divide both sides by what? 0.25 what? Volume per volume. So we can make V1 the subject of the formula. 0.25% volume per volume. So this one will cancel what? So that means V1 is now equal to what? Percentage volume in volume will cancel percentage volume in volume. The only unit here now is 5 liter. Oh yeah, multiply 0.05 times 5 and divide it by 0.25. What's the answer? 1 what? 1 what? 1 liter. So that means they took 1 liter of this initial concentration, 1 in volume of 1 in 400 400 volume per volume of a solution. They took 1 liter of it, add about how many liter? The final volume is 5 liters. So how many liters did they add? No. They took 1 liter of the stock solution, which has concentration of this, and diluted it to form this concentration, which has this volume of 5 liter. So they started from 1 liter and ended up in 5 liter. How many liters did they add? Huh? How? They took 1 liter of the stock solution and added water in it to dilute it to a different concentration, which has volume of 5 liter. How many liters of water did they add? What's going on? I'm confused. You took 1 liter of a stock solution and add water in it to dilute it. The final volume you formed of the new concentration is 5 liter. How many liters of water did you pour in that 1 liter to get 5 liter? Gideon. You took 1 liter of a stock solution. Didn't you do practical in the? You are discussing practical. You took 1 liter of a stock solution. This is a stock solution, only concentration of 1 in 400 volume per volume. You took and you want to dilute it. How do you dilute? With water. You pour water, then afterwards pouring water, the final volume you got is 5 liter. So how many liter of water did you pour in that 1 liter to get 5 liter? You pour 1 liter in 1 liter to get 5 liter. What are you saying? You get 1 liter of 1 liter. Not vehicle now. What is a stock solution? It is a solution with which you will take and dilute. Do you know the meaning of the dilution in the first place? What is the dilution?
Dilution is to mix
to do what? That is not the dilution. Dilution is to make something for the concentration of something to come down. If you make tea, the tea you make is thick. It's straight thick, and you pour water to make it to be a bit watery. What did you do? So what are you saying? You make pap. The pap is too thick, highly concentrated. You pour more water to make it. You see, after cooking soup, the soup you cook is so thick. You want it to be at least diluted a bit so that the volume will increase, so that you can be enough for people in the house. What will you do? You put water now so you can get more volume and lesser concentration. Now, that thick solution is one that is concentrated, which is 1 liter in volume. And concentration is 1 in 400 volume in volume. And you are asked to dilute it. You pour water in it. You pour water in it. Having poured water in it, the final volume of what you got the diluted one you got, the final volume is 5 liter. So what is the amount of water you added in that 1 liter to be able to get 5 liter? Huh? Gideon, I'm confused here. On a more serious note, I am confused. This thing this thing is nothing to even think about. What are you saying? You have 1 liter and you want to produce 5 liter. What will you do to that 1 liter to get 5 liter? What will you earn and what is the volume of water you add to get 5 liters? That's the question. I'm asking. You don't know. Wow. You have 1 liter of a solution, which is a stock solution you are working with. From this stock solution has a concentration of 0. Which we converted to 1 in 400 volume, which we converted to 0.25% volume. And you want to dilute this thing, and you diluted this thing and form another solution which has volume of 5 liter. And the concentration went down from 0.2. The volume increased from 1 liter. When you added water, the volume increased from 1 liter to 5 liter. But the concentration, because you diluted it, the concentration went down to what? Is that not what we did here? To 0.05% volume. And you ask, what is the amount of water you added to this now to be able to get 5 liter? Is this volume? What are you saying? This is the concentration. This is not volume. Now, see volume 5 liter, 1 liter. What is the volume of water you add to this to get 5 liters? $1,000. Think about it. If you crack your brain, if you're able to think out something, let me know. Let me go back to my office. I have a lot of things to do. I'm so disappointed that you don't know that what you can do to 1 liter of water to get 5 liter. At this level, no. I can. Convert what? Gideon. Think about. I have another lecture by 4 p.m. Think of what you do to this to get 5 liter. If you remember, come. You should know this thing. You'll be doing proper practicals. When you're done, call me on your phone. Look up. Let me help you. Maybe after this description, maybe you'll be able to answer it. This is a bottle, right? This is the bottle, right? This is a cover. Let me use this to describe this. Now, you know that if you dilute something, if it is concentrated, then this cup, it dilute to the water. If you, I'm speaking Igbo language. Okay, this thing now is a cup. Inside this cup now, let's say you have 10 ml. Let's say this is where you have the 1 liter. Even though we know that 1 liter is bigger than this, let's just assume that if you have the 1 liter here, now you pour the 1 liter here. This one is the one that has the concentration of 0.25%. You now pour it here and add water until water get to 5 liter. Let's say somewhere here. You shake it. The concentration will go down, but the volume will increase. The question is this: What is the amount of water you added inside this thing to make the volume to increase to 5 liter from 1 liter? Calculate it now. You calculate it since you know the initial volume 1 mil and the final volume you got is 5 mil. What is the volume of water you added? You calculate it. This forget about that thing is concentration. I'm asking you for volume of water added, not concentration. Why do you always go to this concentration? Forget about. I'm just asking you. We have solved this question. I'm just asking you some things to help you understand some things about dilution. That's why I'm asking you this question. Forget about concentration. What do you use in dilution in this type of the dilution? What diluent do you use in this type of the dilution? This one we did now. What would you do? What do we use to dilute it? Is not water? What's going on, Gideon? I'm confused. Seriously, you're making me feel so somehow. Why didn't you eat? You're coming to class. You should have eaten now before coming to class. Now look at it now. This 1 liter and you add water inside it to dilute it to form 5 liter. What is the volume of water you added? That's the question. No. Gideon, subtract 5 liter from water from 5 liter. You get 4 liter. What's your problem? This thing has this thing. You pour water inside it, increase it to. If 1 liter is here, as you are pouring water, won't the volume increase? If you get this now, this is 1 liter. You pour inside this bottle. It will be here, right? And you want to dilute it. You are pouring water. The volume will be increasing until if you get to 5 liter. I'm asking you now, what is the volume of water you added inside this thing? Is it the marrow? 0.25 from where? This is confusing. Seriously, I'm surprised. I'm giving you time to think about this. Now, the volume of water you added is not the final volume you got minus the initial volume, which is what? Yeah, it's 4 liter of water you added now to get 5 liter. Such is life now. That's the training. That's the training. You tomorrow you go out there to work. You see people, you see patients that are sick. They will asking you question. Will you tell them the way they will ask you a question? I want you to tell you is when you develop your thinking this thing. As the patient is even talking, you already know what the patient is saying, because as the patient is saying, you are listening immediately, you are fast, you are thinking fast. This is just a method of thinking, reasoning. Okay, this should be there. Okay, it's not an issue. It's not a something you cram. It's something you can easily reason out straight. It's not. Yeah. Hey, Gideon, you made me shout this. I don't like shouting. You made me shout this evening. You made me shout. It's simple. 5 liter minus 1 liter is 4 liter. Simple. This is not part of, we have gotten the answer. This is not part of, but I'm just trying. There's some question. There's some question you will see. The question will ask you, what is the volume of water added? What is the volume of water used to dilute it? That's why I'm trying to let you know how to check it. Just simple. Final volume is 4 liter of water you added to dilute it. It's not. Okay. Any other question?
are required to make the following single strength chloroform water. And they give us this form 40 mil, 50 mil, 100 mil, 200 mil, 300 mil.
Okay. The question says, what volumes of chloroform water concentrate are required to make the following volumes of single strength chloroform water? Now, in chloroform water, when you're dealing with chloroform water, I told people that it should be in what is it called again? Look at the board. Okay, now listen. Sorry. Look up. In our class, in our normal lecture, I told you something about chloroform water. I told you that chloroform water come like a concentrate. You know what the concentrate is? Like stock solutions, or it can be in solution form. I think mainly in solution form. Yes, a concentrate may even be in solid form. You are the one to put water, dilute it. Okay, it can come as a liquid, but it's highly concentrated. Now, see how they do it. If you want to prepare single strength chloroform water, if you want to prepare a single strength chloroform water, we have 1 part of chloroform water and the 39 parts of what? Water. It's actually one. If you add 1 part of chloroform water to 39 parts of ordinary water, you have 40 what? Parts. Do you know why I didn't want to use male? Because the volume can increase. They may ask you to produce 100 ml chloroform water. What it means is that inside that 100 ml, 1 part of it is what? Chloroform. The remaining one is what? Water. That means you divide. What it means that you divide that 100 ml into 40. One of it is chloroform what? Is chloroform water. The remaining one, which is 39 parts, is what? Water. Simple. Now with that, let's assume you want to produce. This is for single strength, but for double strength, 2 parts is chloroform. The remaining 38 is what? Water. Making it 40 parts. Now, let's assume you are asked to produce 100 ml chloroform water. Divide 100 ml by 40. 100 ml by 40 is what? So that means 2.5. You get 2.5 ml of what? Chloroform. Because this is 1 part. Hope you know. Then you add the 39 parts. If 1 part is 2.5 ml, multiply 2.5 ml by 39. What will it give you? At 97.5 ml is now ml because you want to produce 100 what? Ml. Are we together? That's what you want to produce 100 ml single strength. Inside that 100 ml, 2.5 ml is what? Water. 97.5 ml is what? Sorry, 2.5 ml is what? Chloroform water. Then 97.5 ml is what? Water. If you add them, it will give you what? 100 ml. So how many ml were we told to produce? First one is what? Okay, let's start the first one. You want to produce 40 ml, right? Remember, look at it. Remember, the total parts must be what? 40 parts. So do 40 ml divided by 40 is what? So one chloroform will be what? 1 ml. Then the remaining 39 ml is what? Water. Is it clear? Now, oh yeah, what other volume are we told to produce? You want to produce 50 ml. Divide 50 ml by 40. So you can get one part. One 1.25. So 1.25 ml is what? Chloroform. The remaining one is either you subtract. Is either you subtract this 1.25 from 50 and get the remaining one, which is what? For water, or simply multiply 1.25 by 39. It will give something. Subtract this from 50. Tell me what it is. No, 50 minus 1.25. Oh, you mean that's what I mean. 40 what? 0.75 what? Mil. I multiply 39 by 1.25. It will give you the same thing. Yes. Did you understand how to do this now? So this is what you do with all the volume. Oh yeah. What is the next volume?
100.
Okay, we have done 100. Next one is what?
200.
Oh yeah, do for 200. Tell me what 200 will be. Do for 200 fast. Huh? 5 what?
Yeah.
The remaining water is now what? Which is what? No, he came 34. How did he get to 34? 100 and what? 195 mil. Oh yeah. The next one is what?
300.
Oh yeah. Calculate for 300 mil. Here is chloroform. And here is what? Water. For single strength. This is for single what? Seven what?
7.5. 67.5. For chloroform. For water, sorry. 67.5.
7.
67.5.
It comes in 7.5. Please check well now. See, some of this and this must give you the volume you are producing.
292.5.
So this is what you do for this entire thing.
So in this in double strength,
You multiply
by this
for water. But remember, you first divide everything by 40. Multiply by 2 is double strength. You multiply for chloroform water. Instead of using 1 part for chloroform, use what? 2 parts for chloroform. The remaining one is water. Do you understand? Like now for double strength. Now, if you want to produce 40 ml, the double strength, here become what? 2 ml. For 40 ml. And here become what? That's 8 ml. You want to produce 50 ml. Remember that if you divide 40 by 50, you have what? If you divide 50 by 40, you have 1.25. That is for 1 part. Double part, you multiply by 2, which is what? 2.5. So water should be what? Hmm? 90?
95
No.
2.5.
No. See what you do. This is sensible. You are not increasing the volume of water. We have 40 parts in all. 2 parts is for water, is for chloroform. 1/38 part is for what? Water. So if you divide 50 ml by 40, you have what? 1.25. So 2 parts is 1.25 ml times 2. You get that of what? The 1.25 ml times 38. You get that. You get that of water. Water. Do it. Good. 47.5. Then add the two of them, you get 50 ml. But this the water now, chloroform is double here, and as against here where it's here single. So do for 100 ml. This is double strength. Chloroform water. Do for 100 ml. So you can do for 200 ml, 300 ml, 400 ml, and what? 500 ml. Complete this one. Complete this one. Look up. Complete this one for 400 ml and what? 500 ml. No, I'm coming. We have 22 minutes. Do you want to go now? We have 22 minutes to finish. I'm coming. Let me take water. I'm having hiccups. Huh? Here's what?
Water is
10 mil. Water. Chloroform. 10 mil. Water. Is it water or chloroform? Which are the chloroform water? Look at this.
And water is 190.
190, okay.
And 300. Chloroform is
15.
And water is
285. Okay.
For 400. Chloroform is 8. And water is 380. 500. Chloroform is 25. And water is 425.
Here, uncle. For 400 here.
400. Is 10. Chloroform.
Here, uncle.
390.
390 mil, Here, uncle.
15. 15 chloroform.
Check well.
It's 15.
No, it can be 15. Divide 500 mil by 40 parts. What did it give you?
12.5.
12 what?
0.5.
Here is now what?
487.5.
487 point what?
5.
Now look at these two things. Compare the double strength. Compare with single strength. You know at any volume, this is the part of chloroform is double the part of here. That's why it's double strength. Why this one is single strength? Okay, let's look at 40 ml. For when you want to produce 40 ml of chloroform water, chloroform is 2 ml for double strength. Here is what? 1 ml. Now look at for 200 ml. If you want to produce 200 ml chloroform water, here chloroform is 10 ml. Why for 400 here? For 200 here is 5 ml. So this is double. This is what? Single strength. Is it clear now? Is it clear? Okay. Okay, so you can select another question from another topic. Or maybe I may have to, maybe in our next class, I may have to give you people how many questions you can select from each of the topics.
Okay. Isotonic solution.
Isotonic solution. Number 9.
Look at that. Zinc chloride is a 3-ion electrolyte.
Okay.
Dissociating 80% in a certain concentration. And the question is calculate its I factor.
Okay. Zinc chloride is a 3-ion electrolyte. Dissociated 80% in a certain concentration. Calculate its I factor. All right. So please, I think let's stop here for today, please. In our next, I'll post in the what is it called? This the final schedule for our revision on WhatsApp group. That's what will guide us till you will write your exam. Okay. All right. Thank you.